Now here the question is, find the coefficient of x to the power r in the expansion of x plus a to the power n minus 1, x plus a to the power n minus 2, x plus b, x plus a to the power n minus 3, x plus b square, and this series, it continues all the way up to x plus b to the power n minus 1. So this power of x plus a, it starts from n minus 1 and it goes all the way up to x plus a to the power 0. So in this expansion, there are n terms. Now in fact, it's a geometric progression whose first term is x plus a to the power n minus 1 and its common ratio is x plus b upon x plus a. So I'll find the sum of this geometric progression and I can write it as x plus a to the power n minus 1 and then 1 minus, now what's the value of r? Value of r is x plus b upon x plus a, number of terms is n, and then 1 minus x plus b upon x plus a. Now I can write it as x plus a to the power n minus 1 and here I'll get x plus a to the power n minus x plus b to the power n upon x plus a to the power n, and here I'll write, so here x and x will cancel, so I'll get a minus b upon x plus a. Now x plus a to the power n minus 1, so it'll cancel n minus 1 times and then x plus a will also cancel. Then I'll get 1 upon a minus b and then x plus a to the power n minus x plus b to the power n. Now from this series, I'll need to find coefficient of x to the power r. Now if I write general term for this series, I can write t k plus 1 and it will be n c k x to the power n minus k into a to the power k. Now I need this power of x to be equal to r, so I'll write n minus k is equal to r. So that is the value of k is n minus r. So here the coefficient of x to the power r will be 1 upon a minus b n c n minus r and then a to the power n minus r. In the same way, it will be the same for the second expression. So in place of a, I'll have b there. So I'll write n c n minus r and it will be b to the power n minus r. So now I know NCN minus r is same as NCR, so I'll take it common. So I'll write NCR and it will be a to the power n minus r minus b to the power n minus r upon a minus b.